Okay, so on this one, okay, we've got, we're looking for how far, so we're looking for distance. Okay, it's accelerating at positive 4.52 meters per second squared, and it's going from an initial velocity of 123 meters per second to a final velocity of 300 meters per second. Okay, so what formula do I have that can solve that problem in one step? So what formula do I have that would do that all in one step?
Vf squared is equal to vi squared plus 2a times v.
Exactly. All right, but on this one here, I'm looking for d, right? So in order to get d by itself, the first thing I would move would be vi because it's not attached to d. So I'll have vf squared minus vi squared equals 2 times a times d. So I just divide both sides by 2 times a, come over here, and now I'm solving for d. Everybody okay with the manipulation? All right, so when we do that, okay, we're gonna have 300 squared minus 123 squared, not cubic, squared, okay, divided by 2 times 4.52. Okay, now something to be mindful of, you have an addition subtraction operation on the top of this equation, but you have a multiplication division on the bottom. You do need to enclose the addition subtraction operation in brackets. Otherwise, your calculator will do order of operations, and that will mess up the calculation royally. Okay, so you do need to indicate to your calculator that you need this part, 300 squared minus 123 squared, to be done first, okay, and then divide that by 2 times 4.52. Okay, so according to that, it is going to travel, well, 8.3 kilometers. We have 3 significant digits in that, so 8.28 kilometers, or 8.28 times 10 to the 3 meters. Okay, everybody all right with that? Okay, most common problem with that formula is people forgetting to square the 2 speeds. Okay? All right, so a couple of things for this week here, guys. Reminder that your vector assignments are due tomorrow. Okay, start a class, because that's on paper. You're handing that in to me physically, so you don't have to try and scramble in here for 8:30. Okay, just bring it to me at the start of class. And you'll have a quiz tomorrow. Okay, it'll be on acceleration. I think I already have it scheduled to post at 3:20. And you will get this unit's review package. I have it scheduled to post Thursday at 3:20. Okay, so you'll have about a week to use that, okay, because your unit exam is going to be on the 14th of March. Right? Tomorrow, after the quiz, we're going to be doing our lab on acceleration. Okay, it's a pretty straightforward lab. You're going to run a cart down a ramp. Okay, we're going to use the little app that we had for the last one to record its speed over the course of that length of time. Okay, pretty straightforward. We'll be graphing some velocity versus time graphs, get a little bit of review of velocity versus time graphs, because it's been a while since we did that, before we move on to projectile motion, probably Wednesday or Thursday. Okay, kind of depending on how the acceleration quiz goes tomorrow. All right, questions there? Okay, so today is going to be just doing acceleration problems, learning how to figure out which formula to use, getting some practice using them all, okay, so that tomorrow's lab goes really efficiently, and then we'll move on from there. Okay, like I said, acceleration is mostly algebra, okay, as long as you can figure out which formula to use. I trust you guys and your ability to do algebra, okay? Okay, try that one. Looking for the initial velocity on that one. Okay, so we're looking for the initial velocity, okay, of a runner who finishes a race at a velocity of 15 meters per second. So that would imply that's the end, or the final. Okay, if the race was 150 meters long, and it took 21.2 seconds. Okay, I'm not given the acceleration in that one. What formula am I gonna use? I have all day. I have tomorrow and the next day.
D equals VI plus VF divided by 2 times 2.
Exactly. VF plus VI over 2 times T. That's the only one that I have all of those parts except for VI. Okay? So, if I'm looking for VI, then I'm going to first divide both sides by T. So T comes over here. That is going to eliminate the need for these brackets. Okay, so they can get out of here since there's nothing else on that side anymore. So then the next thing I would want to do is multiply both sides by 2 and then subtract VF. So I'm going to have 2D over T minus VF would equal VI. Okay, so that's going to be 2 times 150 divided by 21.2 seconds. Okay, so that would mean then that their initial speed was, oh, sorry, I forgot to subtract. Sorry. Subtract the 15. Okay, now, that came out negative. Is that okay? I mean, within the context of the question, some people don't like if this one's negative because it means they were doing what at the beginning of the race?
Accelerating back, no.
Not accelerating, but
Moving backwards.
moving backwards. Okay? And sometimes people are like, oh, that's not right. You never move backwards at the beginning of a race. Except you do sometimes. Okay? Sometimes if people are kind of jittery in a race, they'll rock back to their back foot. If they're in starting blocks, they'll rock backwards onto their back leg in the starting blocks, which would imply they would have had an initial negative velocity when the gun went off. Okay? So there's that possibility. Right? Now, if it had said -5 meters per second, then I think you'd have had a legitimate gripe about how the context of the question didn't make sense, or the answer didn't make sense within the context of the question. Nobody's running backwards at 5 meters per second when a race starts unless they've gone crazy. Okay? But this small negative number would be not unreasonable. Okay? It maybe doesn't feel good at first when you first see it, but once you kind of get the explanation, hopefully it makes a little bit more sense for that one. Okay? All right. Questions there? Okay, so now we've seen several examples for each one of the formulas that you have on your formula sheet. Okay? So what I'm going to do now is just throw some up there, okay, for you guys to try, and you're not going to know which formula they go with. Okay, you're gonna have to figure that out for yourself and then see how you do. All right, so these questions are actually in the digital workbook. Okay, so they come from your acceleration worksheet. I'm just gonna circle the ones I want you to do first here. Okay, so the ones I would like you to do right now are number 2, number 4, number 5, and number 8, and let's see, number 10. Okay, I'd like you to try those ones for right now. Okay, and then we'll go through any of those that give us trouble. Okay, so on number 4, okay, we've got this, so imagine like the Large Hadron Collider. That's a particle accelerator. Okay, so that's the kind of thing we're talking about here. Okay, proton is accelerated in an accelerator. The accelerator is 0.8 kilometers long. What do I need that to be in? Meters. Okay, so the distance traveled by these particles is going to be 800 meters. Okay, how long does it take, time, okay, to get a proton from rest, okay, so VI being 0, okay, to 2.5 times 10 to the 8 meters per second. Okay, so we don't have the acceleration. That's okay. We just did a problem that uses this formula. D equals VF plus VI over 2 times T. Okay, so if I want to get T by itself, I just divide the whole bracket over to this side. So I'll have D over VF plus VI over 2 equals T. So when I plug in my numbers, that's going to be 800 divided by 2.5 times 10 to the 8, okay, plus 0 divided by 2. Okay, with me so far? Okay. Is this a very big amount of time? It's a very small amount of time. Okay, so let's just make sure we get that number. So 800, okay, divided by, and then we'll have in bracket 2.5 E8, okay, divided by 2. Okay, 6.4 times 10 to the minus 6 seconds. Okay, so is that a pretty big acceleration, do you suppose? Yeah, it's huge. But remember, a proton is also really, 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 really small. Okay? It doesn't take a whole heck of a lot of energy, okay, or time to get something so small up to a speed so great. Okay. All right. Any others giving us trouble there?